All right, I talked to you guys about waka. Waka. We should probably do that, like the someone a Jewish would, a Jew person. How do you say that? How a Jewish person would say it? What the? Yeah, wach. Whatever.
That's pretty good.
So the W is actually called an omega. He's a Greek symbol. But what I'm going to do is I'm going to draw my cheat graph. And I call it a cheat graph because I change the numbers on the x-axis and the y-axis. And then I'll put it on another graph that is already scaled for us. So here's my cheat graph. To do a cheat graph for sine and cosine, you just need to have 1, 2, 3, 4 tick marks. And the last tick mark, you need to have your period. Their period has to be there. So that's where the W comes into play, or the omega. This right here is pi, is the one that's multiplying to the x, so that's going to be your omega here. Let me write this template down really fast. We have a times cosine, and you could change cosine to say sine, w, or omega, times x minus h plus k. Alright, so the pi is our omega, our w. Now, sometimes you don't see your functions like this. Sometimes you see it like this. Like it says negative 2 cosine. Then it'll say pi x minus 3 pi. Then it'll put parentheses around it like that and say minus 1. If it says that, then you just have to take the extra step to factor out the pi so you can see what your h is. Okay, all right, back to business. What's our w? Our w is pi, and pi changes the period of the function. What is the period of the normal cosine function? 2. Here's a normal cosine function. I want to write him because we're going to refer back to him later. 2 pi is the normal period of a cosine function. So we're going to take that pi right there and take our 2 pi and we're going to divide it by pi. I thought you said multiply by the reciprocal. Yeah, multiplying by reciprocal does the same job. So if I multiply this by the reciprocal of pi, that'd be 1 over pi. I just like saying multiply by the reciprocal because if you ever do come into contact with fractions, we multiply by the reciprocal. So these pi's will cancel out and I'd be left with 2. So that is our period. Our period is 2. After that, after you find your period, you want to find your other x values. And to do that, because there's 4 sections right here, we're going to divide the 2 by 4. So it would be 2 divided by 4, and that would give me 1/4. Is that right? No. 1/2. Okay, so I'm going to count by 1/2. So 1/2, and then if I add 1/2 again, what would that give us? 1. And if I add 1/2 again, what would that give us? 1 and 1/2. And then I add 1/2 again, that would give me a 2. And so we're clipping along right now. We got our x numbers. We have our period. Now what about this guy right here? What is the 2 do to the cosine graph? It stretches, it pulls apart the max and min. So the 2 actually means amplitude. Amplitude means the spaces away from the midline. And right now our midline is right here. So we need to go 2 spaces away from the midline. Now on our regular cosine graph, how many spaces do we go from the midline to go to the max or to go to the min? How many spaces is that? That's just 1. It'll just be 1 space. That'd be 1, and this right here is 1. Okay, but now because of this 2, we're going to go 2 spaces away from the midline. So I'm going to go 1, 2, and I put a dot right there. But wait a second. There's a negative right there. What does that do to my function? It flips it. So instead of us starting on the 2, like the 1 right here, we're going to start on a negative 2. So we're going to go down 2 and put a dot right there. And then you follow the pattern. The pattern is this. Well, it used to be max, midline intercept, min, midline intercept, max. But now we're starting with the min. What comes after min? Midline intercept, and then max, and then midline, and then min. So now I have a picture of what my graph looks like so far. But we're not done because there's other things that are affecting my graph. And look, I don't have any numbers on my y-axis. How do we find those numbers on the y-axis? Well, the next thing to do is k. So we did the w, which was pi. We did the a, which was -2. Now we do the k. What's the k? Is the k the 3 or the 1? It is the 1. Now it says -1. So what does that do to the graph? You guys remember when we did all that work, that activity? What does that number do to the graph? Shifts it up or down. So if it says -1, what's the shift? Down 1. And so that means this x-axis is not an x-axis. It's still a midline, but it's not an x-axis. What is that line at? It's at -1 because it shifted down 1. That's why it's good to know where the midline is. And then I go up 0, then 1, then 2, and then this would be down -2, -3, -4. Okay. So now we can see what our max and mins are. Do you guys see what our max and mins are? Yeah. Okay. We took care of this number, this number, this number. Now we have one more number that affects our function, and that is the -3. Now that -3 does what to our function? Shifts it left or right. This is also known as a phase shift. Now it says -3, so what's my phase shift? Phase shift, whoops. Do I go to the right or the left? You go to the right. So our phase shift is +3. You always got to think the opposite. Does that make sense? Okay, so that changes our x numbers right here. Now, I don't like making more changes to my cheat graph. I like to now go over to the regular graph and then graph that. But if you wanted to, you could change this 1/2 to something else. What would that 1/2 be? It'd be 3.5 or 3.5, right? And what would this 1 1/2 be? That'd be 4.5 or 4.5. You guys understand? All right. Actually, that kind of helps right there, because now when I go to my already scaled graph, let's see. Let's go to our already scaled graph. We'll scale this graph. Since our period is not does not have a pi in it, hold on, I'll answer your question in a second. Because our period doesn't have a pi in it, I'm going to count by regular integers. Okay, so I'm going to go 1, 2, 3, 4, and this is 5. This will be 6, and then this last one will be 7. We'll stop at 7. Okay, so we're counting by ones there. So our midline, when we go over to this, is going to be right here at -1. We'll just let this count like 0, -1, -2, -3. This would be 1, 2, and then 3. And then on our midline, we're going to put our midline intercepts. Where are our midline intercepts? That's this guy and this guy. So we're at 3.5 and 4.5. So 3.5 would be right here. So I'm going to put a point right there. And 4.5 would be right there. Once you have your midline intercepts, follow the pattern. And then put the rest of them on there. What's the space between these? From 3.5 to 4.5 is just 1, right? So I'm going to count 1 space, 1 space, 1 space. And I'll go the other way, 1 space, 1 space. Do you guys see what I just did? I call this the Omar method. Okay, so no, I haven't got his picture yet. Sorry, but here we have these two points which are reflected over here. You guys see those 2 points right there? They're the same points. So I have a question for you: is there a max or a min between these 2 points? Is there a max or a min between these 2 points?
A max.
A min.
Wait, which one?
Guys, I just circled them. Here, I'll put them back.
Oh no, there's a max.
There's a max between those 2 points. And so I'm going to go up to my max right here, put a dot. And now that you have a max, you know where the mins are. And you know where the other maxes are. So let's just do the pattern stuff. We're going to go down to -3, up to 1, down to -3, up to 1, down to -3, up to 1, down to -3. And then I'm going to connect the dots. Make sure you make it curvy. All right. Any questions? Awesome. I hope that helped.